All right, Cramer's rule. Cramer's rule is another way to solve systems of equations. I'm going to do the first two examples with a linear system of equations with 2 variables, and then tomorrow I'll do 3 variables. We'll do it in small parts. I'll upload the whole video tomorrow, so the whole thing is together. And then so I say tomorrow. I mean, today we're doing the first part. Monday we're doing the second part. Then Tuesday, Wednesday is going to be review with the seniors and their test. If you have anything missing, you can take it at that time.
Yeah, you sent it.
And then Thursday, Friday, we're going to practice Cramer's rule. And then we're going to do just some completing the square and some circle stuff the week after. So right now, the final for the seniors, I just finished it. It's 27 questions. Yours will probably be 32, 33, something like that. You'll have a couple extra, yeah. But that's the only thing. You'll have 2 homework assignments, but we'll work on them in class together.
We won't have a quiz?
No quiz. There's not enough time. So we'll just work on homework assignments together, that we should be able to submit them by the end of class, that sort of thing. So when we're talking about Cramer's rule, okay, you guys we haven't learned yet about matrices. You will probably learn about matrices if you take pre-cal next year, advanced topics. If you go into stats, that's more of an English kind of course. But matrices are it's another way to solve equations. This is the matrix notation. Looks like a big bracket. You guys see that? It's like a big bracket. It's not a parenthesis or anything like that. It's just a big bracket, and that denotes a matrix. So when you're solving, the basic behind this is when you're solving, however many variables are in your equation. If you have an x and a y, that's 2 variables. If you have an x and a y and a z, that's 3 variables. You're going to determine the determinant for each variable. You're going to have d sub x, d sub y, maybe d sub z, and you're also going to find the coefficient determinant. And that sounds like, oh my gosh, what? It's not hard at all, I promise. I'll show you. There is a method to it. Now, you guys would take a question like this, and if it just said to solve, you would multiply the top by +2, and you'd use elimination, and that'd be the end of it, right? But here, we're going to use Cramer's rule. And you wouldn't use Cramer's rule for something basic like this, but for those Gaussian elimination ones that we had 3 variables and 3 equations, and you had to take the first and the third and eliminate, and then the first and second eliminate, and then combine and eliminate, and it got really hairy, this is where Cramer's rule would come in handy. So we're going to solve this using Cramer's rule. I'm going to teach you how to do it today with a 2x2, they'll call it, because there's 2 equations and 2 variables. And then Monday we'll talk about 3x3s. So down here is the explanation of it. I'm going to actually work through it with you. So the first thing I want you guys to do when you see these equations is make sure they're in standard form. Does your equation, does it say x, then y, equal sign, answer? Do each of them say x, y, equal sign, answer? Yes. Okay, good. So we're going to find a determinant for each variable and for the coefficients. So how many variables do I have here? 2. I have 2 variables. I have an x and a y. So I'm going to find the determinant for my coefficients. That's the first thing we find. Then I'm going to find the determinant for my x's and the determinant for my y's. And I'll show you. The first we do this, you're going to be like, wait a second, huh? And then you're going to be okay, I promise. So the D, that's just by itself, that's your coefficient determinant. That means you want just the coefficients of x and y. You don't have to put little brackets on it. If you just want to put straight lines, it's fine. You don't have to do this after I do this in the first example. I'm just showing you. But you're going to have an x column and a y column. If you had 3 variables, you'd have an x and a y and a z. So for a coefficient, this D by itself is just your coefficients. What are the coefficients of x in this set of equations? What are the coefficients? 2 and -4. Yep, so just write them on top of each other. That's your x column. So what are the coefficients of y?
-5 and 3.
Good, -5 and 3. And the way that we determine what the determinant is you multiply, we're going to call it the majors and the minors, and we subtract. You're going to start right here. You're going to multiply from top left to bottom right. So you're going to say 2 times 3. Everybody with me? And then you multiply 4, or negative 4, and negative 5. And we're going to subtract those values. It's always major, which is top left, bottom right, minus the minor, which is top right, bottom left. So you start like a crisscross. So when you multiply this together, what's 2 times 3? 6 minus, what's negative 4 and negative 5? Positive 20. So 6 minus 20 is what? Negative 14. So your coefficient matrix, your D, equals negative 14. Everybody with me? All right, now let's do the same thing, but we're going to find the determinant of X. Now, how this is different, whatever column you're trying to find, instead of the coefficients, you plug in the answers. So watch what I do here. I have X and I have Y. I'm trying to find X, right? This is D sub X. So I'm going to plug in the answers for that column. What are the answers to these two equations? What are the answers? 3 and 8. So I'm going to write 3 and 8. And then what are my Y coefficients? Negative 5 and 3? So negative 5 and 3. So now we're going to do the same thing. We're going to multiply the major. So 3 times 3 minus the minor, which is 8 times negative 5. If you did negative 5 times 8, same thing. But what is 3 times 3? 9. And then negative 8 times negative 5 is plus 40. So what's 9 plus 40? 49. So your D sub X is 49. All right? We're going to do a couple of these. Now I'm going to do the same thing, but instead of finding D sub X, I'm finding D sub... What letter am I finding? D sub Y, right? I have my little Y. So what are the X coefficients? What are the X coefficients from here? 2 and? Okay, 2 and negative 4. So 2 and negative 4. Now I'm trying to find Y, so what do I plug in for the Y column? We're trying to find X. What do we plug in for the X column? The answers, right? So same thing. I'm trying to find Y, so what am I going to plug in for the Y column? The answers. What are the answers? 3 and 8. So 3 and 8. Whatever little variable you're trying to find, that's where you put the answers. So again, major, so 2 times 8, minus the minor is negative 4 times 3. What is 2 times 8? 16. Minus, what's negative 4 times 3? Negative 12, right? What's 16 minus a negative 12? It's plus, and that gives me 28, right? Okay, so now you guys are like, okay, what was the purpose of this, right? Well, think about this. I have 2 variables, right? So my answer is going to be an ordered pair. It's going to be an X and a Y. What was your D sub X value? What was your D with a little x? What was your D sub X value? 49. 49, good. Write that down. Comma, what was your D sub Y value? 28, all right. And what we do with that is we divide everything by the coefficient determinant. So I'm going to say, okay, divide this by negative 14 and this by negative 14. So when I do that, when I divide by negative 14, does 49 divide by 14 nice and pretty? No. But can you simplify? Does 7 go into both? Yeah, 7 goes into 49 7 times, and 7 goes into negative 14, negative 2, right? Yeah. And then what's 28 divided by negative 14? What kind of 2? Negative 2, and there's your solution. Now, again, you would not do this with this basic set of equations, but you will when you have 3. We call it a 3 by 3, and you'll understand. So you don't have to do that Gaussian elimination. It makes things so much easier. Let's do this Let's do this next example. If we do this next example, okay, this one's not as simple as the last one. If you were going to use elimination, you'd have to multiply the top and the bottom by both by numbers. One had to be negative, one had to be positive. So let's do Cramer's rule. So remember, you have to find the coefficient determinant, and then you have to find a determinant for each variable. So how many determinants am I going to find here? I have to find 3. I have to find 1 for my coefficient. I have to find 1 for my x's and 1 for my y's, right? Okay, so So this one's going to go a little quicker. You guys are going to be like, okay, we got this. So to find my coefficient determinant, I just write the coefficients. So what are the x? What's the x column? 4 and 3. Perfect. What is the y column? -2 and -5. Everybody with me?
Yeah.
Okay, so now we're going to multiply the major, top left, bottom right. So I have 4 times -5 minus, make sure you put a minus there, times the minor. So it's 3 times -2. What is 4 times -5? -20. And then I have minus a negative,
It's plus.
right? It's going to be plus because I have 2 negatives, so plus 6. And then what's -20? Plus 6. -14. It does not always equal -14. I don't know these two examples. That's funny. Okay, so now let's look at d sub x. Meaning, instead of x, I'm trying to find x. So what do I put in for x? I put in the answers. So I have 10 and 11 here. My coefficients for y, so -2, -5. And again, we're going to do the same thing. Multiply major, top left, bottom right. 10 times -5 minus -2 times 11. Okay, so -50 plus 22 gives me negative what? -28? Okay, so d sub x is -28. So I found this one, and I found this one. Now let's find d sub y. So I'm looking for y. That means what do I plug in for y? The answer. So I have 4 and 3 for x, and then I have 10 and 11 for y. We're going to do the same thing again. So we're going to multiply 4 times 11. So 4 times 11 minus 3 times 10, right? What's 4 times 11? 44 minus 3 times 10 is 30. What's 44 minus 30? 14. So, all right, girls and boys, we found these wonderful numbers. What do we do with them? So think about this. Our answer is going to be an ordered pair, correct?
Yeah, so you take the.
You take your d sub x,
And d sub y.
28, and you take your d sub y, 14, and you divide it by the coefficient. Yep, you divide it by the coefficient determinant, so -14, -14. What is -28 divided by -14? It is 2. And what's 14 divided by -14? -1. Now, what can I do with that answer to say, oh my gosh, look at me, I'm right? You can plug it back in. But this is kind of cool. I mean, you're doing very, very minimal work. It's very basic. The math is not anything that's over anybody's head. But it's just a different way to solve equations. So sometimes... That was our math department head that made a cameo. All right, so that's just a 2x2. We will pick up on Monday. I know I keep saying tomorrow. We'll pick up on Monday a 3x3. It's a tad more work, but it's just the same thing. You're going to set up your different determinants, find your coefficient, and then you're going to find your d sub x, d sub y, d sub z. We're going to multiply our majors, multiply our minors, subtract them, and then find our ordered pair or ordered triple. Sound good? Okay, thank you guys. I appreciate it.